We're learning new things all the time.
Well, I'm not.
You're learning something.
I'm just coming in and talking into the microphone.
Yeah, but that's the first
Reminding
step.
you what the podcast is about.
That's the first step. Well, what is this podcast about? What is this episode about?
This episode is a conversation with Alice Mauchline from the School of Agriculture Policy and Development here at the University of Reading. And we had conversations about agroecology, precision farming, changes to technology in farming, nature recovery in relation to agriculture. Yeah.
Sounds great. Let's get into it.
So, Alice, I think a really good, useful starting point would be to ask you how you started out. You know, what led you to be doing what you're doing? What is agricultural ecology, and how did you get into it?
So, I suppose as I was growing up, I was just always interested in watching the animals, the birds in my garden. I was always interested in what was going on, observing interactions between them, looking at new species that were arriving, not just in my garden, but also in sort of the countryside around where I live. And the countryside around where I lived was predominantly kind of a farming landscape. But really, I was most motivated and interested, I suppose, in the garden, animals, wildlife that I was watching. So it wasn't necessarily agriculture as such I was most interested to start with. It was mainly sort of watching wildlife. It was my first interest.
Well, that's fascinating right from the outset, because, as you know, there's a sort of connection you have to a major figure in the history of ecology. There's a man called Gilbert White, who in the 18th century published a volume called The Natural Histories of Selborne, and Selborne was the community in which he lived. And he did exactly what you're talking about doing, which was observing species coming and going throughout the seasons, writing things down. He kept a diary, he wrote extraordinary series of letters, and that kind of material has this sort of grounding and this mythology in the history of ecology as a discipline, which I don't really understand much about, so I'm hoping you'll tell us a bit more about that. But he also had a connection to the college that you studied at, so where you went on to study ecology, Oriel College in Oxford. So what did you learn about there, and how does that play a part in what you're doing today?
So, yeah, that's right. I do have a bit of a connection. Firstly, where I grew up was quite close to Gilbert White's house. And so as a child, we did go and visit his garden where he lived, learnt a bit about his approach. And it wasn't until later on that I then realised that I'd gone to study at Oriel College in Oxford to do biological sciences, where he had studied 250 years before me. But yeah, it's that sort of approach of kind of watching wildlife that really got me into my subject. So at university, I studied biological sciences, quite a broad topic. So I covered all sorts of different subjects, including animal behaviour that I was quite interested in, but ecology as well, and understanding those interactions between the organisms that I was observing and watching, and how plants, animals interact with their environment. So that's essentially what ecology, the study of ecology, is all about, those interactions. But it wasn't until a bit later on, so after I left university, I had a short period of time working at the Macaulay Land Use Research Institute in Aberdeen. And there I worked on the Environmental Change Network. So there, other colleagues had set up a series of pitfall traps where they were collecting insects that were busily going about their business. And we were looking at those populations, how they changed over time. So I was up there just for a short period of time, identifying those insects that were caught in the Environmental Change Network traps. And that sort of started getting me interested in insects as a particular group that I was interested in studying. And I saw a PhD advertised at Rothamsted Research, which is one of the oldest agricultural research stations in the world. And I did my PhD at Rothamsted Research. And that's when my interest in ecology really started to tie up with agriculture. Although I'd done a lot of my sort of observations as a child in kind of farming landscapes, that's where I started to embed my ecology in agriculture.
I think that's fascinating because coming from an outsider's perspective, I think it's really easy to think about agriculture and farms as separate from ecology. You have sort of a worked landscape and then you have a natural, quote unquote, or like wild landscape. And what I think is interesting also to think about is kind of the history of ecology as a concept. because I'm thinking about our galleries, Ollie, I'm thinking about the year on the farm. And I don't think we talk necessarily about ecology. We talk about pests and pest management and vermin and things like that. So I would be so interested to know more about sort of how and when that language changed and how we talk about animals, whether those animals are insects or not, on the farm that like aren't supposed to be there or we don't anticipate being there. I mean, are there any particular technologies or like crafts for pest management you can think of in our collections?
Oh well, we've got fascinating pest sprayers. So for applying pesticides, um, they're like little backpacks, so little rucksacks that you carry and you pump and spray as you're walking. And they came to our collections through, I think, GlaxoSmithKline. So there's a connection to that big sort of petrochemical world. And a lot of that ties neatly into the moment when the museum comes into being. So we describe the museum as having been founded in 1951, but in terms of the sort of history of food and farming and agriculture, that's really critical because that post-war period is also really the moment of what's described as the Green Revolution. This is a sort of massive uplift in fertilizer and pesticides and in pest management of particular kinds. And there's a chemical component to that that comes through in a poster that's on display upstairs in the museum. And it's a death to pests poster that has really strong visual imagery that connects it to the wartime efforts to preserve food security. So there's a character at the top who's wielding, I think, a sprayer, and he's wearing a kind of military style helmet. And then the language used in relation to the different pests, quote unquote, is very sort of aggressive and warlike as well. And that the particular pest in question, Alice will know far more about than me, and whether those really are things we should be worrying about, and whether the same approach would be used today, which I suspect very much it wouldn't. Have things changed since the 50s in terms of pest management of that kind?
Yeah, absolutely. It's a really interesting poster to look at and reflect on how we had that real post-war drive towards productivity and how our farm landscape was very much driven towards that intensive agriculture. And that's carried on. But we're starting to realise that there's some significant impacts for that kind of approach. And that approach towards insect pest control, where everything's being sprayed with insecticide, chemical insecticide, really isn't the best approach. We've got all manner of problems as a result of that kind of approach. So the natural systems that occur in ecological natural systems where we've got plants and insects and pathogens all working within a dynamic kind of ecosystem in our kind of arable and agricultural landscapes, that's really been broken down. We've got large areas of single genetically identical crop plants. We've got insects that then have got an unlimited amount of resource where they effectively move from being insects in the landscape to being pests in our eyes. And that's how we're then controlling them with insecticides. But my research has been about looking at alternatives to the use of synthetic insecticides, using an approach called integrated pest management, where we're starting to think about using biological control of those insect pests within those spaces, and much less emphasis on the use of synthetic insecticides.
So my only previous experience of integrated pest management was in library school, where they told us about like bookworms and silverfish and all of the different insects that really like to eat books and that we would have to try to avoid having in our libraries. And I'm really wondering a really interesting question that's actually completely gone from my mind. But I wanted to know a little bit more about how you define a pest, because I feel like it's one of those very loaded terms, like pest or vermin or whatever. And you said something really interesting about monocultures, where when an insect goes from being in kind of a balanced ecosystem to being somewhere where it has, I think you said, unlimited resource, it then becomes a pest. Is that how that works? How would you define it?
So there are various different definitions of what you would class as a pest. But essentially, when we're thinking in kind of agricultural systems and we're thinking about growing crops and we're thinking about a pest within an arable system, really what we're looking at is any insect or potentially a weed or a plant, or it could be a pathogen. There's different types of pests. But if we think about insect pests, that will start to cause economic damage. So that's almost really what the definition needs to be thought of as well.
Interesting.
So if an insect that's in that environment is likely to cause yield loss, but enough yield loss that it would actually be more expensive to control it using some kind of form of control, then it's considered to be a pest. So it's always looking at these balances between how much control methods that you need to use and what cost that might have, not just financial cost, but also kind of environmental cost. There's this balance. And so there's various different ways where we can move away from using insecticide sprays just as a blanket spray to more sophisticated approaches where insecticides are used maybe as a last resort, but we can think about using sort of biological controls, using other organisms that are there in the environment to control our pests rather than using chemicals.
So in that mid-century moment when the Merle comes into being and they're taking a very blunt approach to pest management, and it's not very integrated and it's not very sympathetic to the wider environment, it's a much more abrupt definition of the pest, really. A bit like historically our concerns in museums and libraries might have been a little bit more worried about the presence of a clothes moth in a collection of woolen historic items, or woodworm in a collection like the one I look after, or bookworms in those libraries you're worrying about, Katie. So yeah, definitely a shift away from a blunt definition towards something that's much more nuanced. But I think that sort of comes into play in relation to the wider aspects of your work as well.
So I wanted to talk a little bit more about oilseed rape, because I feel like that is one of the most visible monocultures. If you are out driving down, you guys don't call it the highway, what do you call it? The motorway. And you see these vast sort of highlighter yellow tracts of land. I feel like that's a real shift in how the countryside looks. 20 years ago when I was coming here as a little kid, it did not look like that. And I wanted to hear more about sort of how that discussion with that particular crop has kind of influenced your work.
So oilseed rape was my study species for my PhD. So my PhD at Rothamsted Research was all about how we could develop integrated pest management approaches for oilseed rape in particular. And the species that I was interested in was the pollen beetle. And so in the 90s, when I was doing my PhD, well, actually late 90s, early 2000s, I started doing my PhD. The pollen beetle pest was of real concern to oilseed rape growers. So oilseed rape originally was sort of a break crop within rotation. So the main crops may be wheat and barley and other cereals, but then those rotations every year as farmers move the crops around their farm between the fields, oilseed rape would be grown one particular year as a break. So that's important for pest control as well, because it breaks the repeated cycle of pests building up for that particular crop in that particular area. So oilseed rape was useful for that. But it also started to become valuable in terms of the oil it produced. New varieties of oilseed rape were developed in the 70s that had lower amounts of erucic acid, which made it more palatable. So it also being used for animal fodder. It was used for oil. But it started having its own value as well in terms of biofuel production. So there was incentives to actually grow more oilseed rape. So large areas of it started being grown in the UK and in Europe. And it started to create significant pest problems because it went from being a fairly infrequent crop to suddenly being grown on very large scale. So our approach was about how can we control these insect pests without the constant use of insecticides. And we were looking at manipulating that pest behaviour using a variety of different semiochemicals. So those are information chemicals that insects use to locate their crops, to locate their host plants. And that was what my PhD was about. Oilseed rape was a very interesting model system for me. But actually, the way in which it's been managed, lots of the original insecticides that farmers could use have been withdrawn. So had integrated pest management been used a bit earlier in kind of the cultivation of oilseed rape in these very large areas you were just discussing, Katie, maybe we wouldn't have quite the same pest problems that we have now. But lots of insects are actually resistant to those insecticides, which are causing farmers further problems. So, quite a complicated story, really.
So, Alice, we've talked a lot about insects and pests, and you mentioned pitfall traps as a way of monitoring and presumably counting the numbers of insects. I wonder whether we could talk a little bit more about monitoring, because that seems like it's really important. I mean, how in the past did people monitor insect numbers, in particular crops, and how do they do it now?
So, thinking back to the oilseed rape story, farmers traditionally would go out, walk through their crops, and count the number of insect pests that they've got at different points in the crop's development. So, it's really important to think about the different stages the crop's at, because certain insects are pests at certain points in development. For example, the pollen beetle is a real pest of the yellow buds. The green buds just before they come into flower. But actually, once the flowers are open on the oilseed rape, they're actually a pollinator. So it's really important for the farmer to know what they're looking at and whether it's a pest at that particular life cycle. So it's quite a complicated story, but having that knowledge by being out in the field, walking through the crop, farmers have the opportunity to really see what's happening in their fields, where it's happening, and what sort of numbers are starting to build. And then we can relate that back to the use of thresholds. So if they've reached a certain threshold, certain number of insects per plant, then that can trigger the farmer to consider an insecticide spray, for example, some kind of solution, some kind of response to that pest problem that's developed, where rather than just thinking, I'm going to go out and spray whether they know there's pest there or not.
Okay. So essentially, farmers are being like Gilbert White in the 18th century, out in his garden, looking around at the environment, or you in your childhood, looking at the wildlife and having a real feel for that environment. Are there new technologies coming in that are maybe replacing that farmer knowledge or shifting the degree to which the farmer needs to be out in the field or doing that counting insects one by one kind of thing? Because that seems like the kind of thing that technologies might be coming in to replace.
Absolutely. There's a whole range of new technologies that are coming to market. Some of them are about predicting. So some of it is about collecting the number of insects that are migrating or moving through the landscape at an early point within the season, so that farmers can see whether this is going to be a very big bumper year for a particular pest species and really be ready to look out for those. So, for example, at Rothamsted, there's the aphid suction trap, and there's a network across the UK. Essentially, it's like a Hoover that has a big chimney up into the sky, and it sucks any insects that are flying at 12 metres and collects them. And on a daily basis, farmers are given this update, so they're given an early warning. That can also be then transferred into text messages, so that kind of decision support tool that farmers are given that early warning. But there's also technologies that are available actually out in the field to sort of help support farmers doing those crop walks and working out what insects are building up where. There's machines now that can send out an infrared beam into the field, and it can track any individual insect flying through that beam, looking at the wings, the wing beat frequency, the colour, the shape of that insect, to give live up-to-date information back to the farmer. So that's just one example of some really sort of modern technologies that are helping farmers make these decisions on what, or understand what's building up, what insects are building up in their crops, and whether they need to think about some kind of response.
I feel like Katie has questions, but I just want to just pick up on that and say I think that represents the kind of shifts of technology that move us further away from embedded farmer knowledge. It's quite interesting because in the livestock management world, historically, farmers would ordinarily be able to recognize the faces of individual sheep or cows within the stock that they're looking after. But increasingly, farmers are using RFID technologies, so they might be scanning an ear tag or something like that to get the knowledge about that specific animal and the number of lambs it's had if it's a sheep, or particular health conditions it might have struggled with. So again, moving the need for the knowledge to be embedded in the farmer's head and placing it in the technology. So it's a little bit like, I don't know, using infrared technologies to have some sort of spidey sense of how many insects are out there, or insect hoovers, which I'm fascinated by. Do you have questions about
I always have questions. I never don't have questions. But specifically, I think you're making really interesting points about thinking about the ecology of the landscape as a temporal thing and not just a spatial thing. So different as you said, different things being pests at certain points and pollinators at others. And I have this fantastical vision of like BBC weather for farmers, where like the aphids are very strong today in this region, or they're not very strong in that region. And you mentioned all this wonderful technology. Is it federated or joined up in any way? Are these technologies that individual farmers are using? Or you said there was a text message system. How does that work? How does that reporting come together? Because as you mentioned about embedded farming, I mean, if I think about sort of like a romantic idea of what a farmer does, he walks the bounds of his farm and makes sure all the fences are together and, you know, none of the calves are sick. And if you think about someone who's walking through, you know, fields of monoculture, how could you possibly get a sense over that giant sort of tract of land of whether the bugs are, you know, what the bugs are doing on any particular day? And also, wouldn't it affect your neighbors, right? Because the bugs don't know whose farm is which. That was like 13 questions in one. Are you ready? Are you ready to answer 13 questions in one?
Yeah, I mean, these technologies are definitely advancing. Some of them, in terms of sort of the early warning system that you were sort of speaking about at the beginning there, and who is providing that information. So some of it is coming through from the scientists, like Rotham said, where they're doing the aphid monitoring. But that information is available on a website, and so any farmer anywhere in the landscape is able to look at that information. And for other key in agricultural pests, there are other organisations providing that sort of information on a sort of annual basis, so that you can look at where some of these pests are sort of regionally most important. But that early warning is really, really valuable. And for farmers to be able to communicate with each other, that's also really useful. So to think about ways in which farmers locally can kind of look at the pests that they've got, but also think about the biodiversity on their farm as well, because pests are living within this kind of complex landscape where we've got monocrops where we're actually growing our food, but there are also pockets of natural habitat and also semi-natural habitat.
What is a semi-natural habitat? Sorry to cut you off. What does that mean?
So a semi-natural habitat is maybe one that's not completely natural. So it's something like a hedgerow, or it's like a flower bank along the side of an agricultural field where it has some element of management, human management, whereas a natural ecosystem is maybe less. I mean, most habitats today have got some element of management, but are less managed. Semi-natural is maybe one that's slightly managed by people.
Interesting.
Yeah. I mean, I think there's a really good point of reference here in the Merrill Galleries, and I've stood with you, Alice, in front of this. It's a huge wall hanging that was one panel from a massive 46-metre-long curtain that adorned the walls of the Countryside Pavilion at the Festival of Britain in 1951. So again, we're coming back to that mid-century moment, the beginning of the Green Revolution, and that uptick in pesticide use and fertiliser and mechanisation that came at the point when the museum was founded. So this wall hanging depicts Cheshire, and it's an artistic representation of what's going on in Cheshire at that point in time, but it's sort of hinting back to the past as well. It's got very modern-looking dairy cows on it, Holsteins or Friesians, and it's got cheeses all over it because Cheshire is known for its milk production. But there are 2 farms on it, and each of those farms is bounded with a very strong, thick orange line defining this as a sort of farm unit. And within each of those farms, particular things are happening. So there's a man with a tractor and a plough. There's someone with a heavy horse, and there's someone feeding some poultry in one farm, and then in the other, we've got different fields with other things going on. Now, there are a couple of things that I remember you commenting on that were very interesting, one of which is there is quite an interesting depiction of autochthonous tree species. So you get big stylized leaves of the kinds of traditional native trees that would have been in this environment. But the farms are very bounded, and there's absolutely no depiction of wildlife whatsoever. So there are certainly no insects, but there aren't even any larger mammals or wild birds shown here. What does this tell us about farm management in the middle of the 20th century, and how would things be different now in terms of the ways in which farms are encouraged to work together and farmers encouraged to share this knowledge about biodiversity and environment?
Yeah, I remember this wall hanging and talking with you, Ollie. It's a beautiful wall hanging. And yeah, you're right. These the way in which these two farms are kind of depicted within the landscape as very sort of isolated units really isn't how the world works. It's not how the countryside works. Wildlife doesn't see the boundary of one particular farm as distinct from the boundary of another. You know, wildlife moves across our landscape at a landscape scale. So whether we're talking about pest insects building up in a particular area, that would obviously impact other local farms. But if we're thinking about enhancing our natural biodiversity, and our natural biodiversity can actually help in terms of pest control, so we can actually have areas within our farms of natural or semi-natural habitat that support things like parasitic wasps or insect predators that can actually eat our pests and do that pest control for us. But just the ability to have insects and other wildlife that live within our countryside in and around the areas where we grow food, that's really quite a shift away from this isolated pockets of this farm's doing this operation, this farm's separate. We have got a matrix of within our landscape. But I mean, one of the ways that I think things are starting to change is that then there are facilitation funds for farmers to work together. Cluster farm groups are forming, which often are sort of around a particular landscape characteristic or around a particular species of interest or of conservation concern, or maybe around the catchment for a particular river. So those farms in a particular landscape are encouraged to work together, communicate with each other, and work on this kind of landscape scale to support, improving water quality, improving biodiversity, improving those connections for wildlife within our landscape. It's quite different.
So what this means is there isn't a world where between farms there are large tracts of weird no man's land populated entirely by giant cheesies that we can just go and pluck like nuggets of gold. That's a great shame.
That's such an interesting point. I mean, even you saying nuggets of gold, the idea here is not that there's a natural landscape, but that there's a cheese matrix. Yeah. And the entire point of the county of Cheshire, surprise Cheshire, is that there's cheese there and we can extract economic value from it. And that is seen as sort of like the background basis of what all these farms are on top of and there to support. And I think it's really interesting, you know, you were saying about thresholds being measured by when does the economic value start to go down and when is that the danger point. The idea that there could be things like parasitic wasps that could actually be of value economically because they're helping to take down pest problems really reframes how we think about what wildlife is for and how biodiversity can help us, because it really is an immediate help to maintaining productivity on farms.
Yeah.
Which is wild.
So the farmers in this scenario are no longer working in isolation, and the farms are no longer sort of bounded entities that are devoid of connectivity to scientists and specialists like yourself, who are part and parcel of the farming process and that conversation. But those more than human elements in here, the insects and the biodiversity itself, plants and animals, are playing a part in these landscapes as well and are allowed to. And I think that's a critical thing, isn't it? It's all part of a sort of complex, holistic whole rather than any single element being valued over the rest of it.
Absolutely. And that sort of brings us back to the need for sort of monitoring and observing and seeing what's going on, because things are changing, our climate is changing. And so we need to know what is happening and what is changing. And so it's really important to be able to observe and track and count so that we can see what's happening in our landscape.
So that brings us to the point of thinking about who's doing that monitoring. Is it just the farmers, or is that something that falls on your shoulders as a scientist and my shoulders as a museum professional who might just be walking through the landscape in question? So lots to think about there.
So you guys have been talking about something called the teabag experiment, which sounds fascinating, but I don't know anything about it. Can you explain?
So the teabag experiment is one of those classic examples of what we might describe as citizen science. I don't know that much about it, but essentially lots of people out there in the world, just ordinary, everyday Joes and Jills like you and me, Katie, were asked to bury tea bags in their back garden. And the decomposition of the tea bags gives you some sort of sense of understanding of the composition of the soil. Is that about right, Alice?
Absolutely. It's an opportunity to look at the microbial processes, the decomposition processes that are happening in the soil, and burying a standard tea bag in that soil for a set period of time and then digging it back up and looking at how much has been decomposed. It gives people the opportunity to explore what's happening there in their soils, in their own location, and then sharing that information with each other to try to understand a little bit more about the scientific process.
So this idea of bringing in lots of people from out there in the community to help and support our understanding of the world is not new. I mean, in some senses, that's what Gilbert White on his own was doing in Selborne back in the 18th century, but it's also played a part in other big rural understanding projects of the past. So a good example of that is the land utilisation survey of the UK, which was undertaken by a geographer called Dudley Stamp in the 1930s. And essentially what he did was he recruited school children to go out and look in all of the fields and make a note of what was in those fields. So is there an arable crop? Is it being left to lie fallow, so nothing going on at that particular time? Are there plants or animals being grown? Are there any other kind of vegetable crops? You know, what's in the fields, note it down, and it's all put on maps. And then you have a really good nuanced understanding of the use of agricultural farmland throughout the countryside. But it's all done by school children. I think health and safety, again, big issue. Probably wouldn't be having school children going out and doing that in quite the same way today. But this still does play a massive part in the ways in which we can gain greater understanding of farms and farmland.
So what I'm interested in is kind of where these big projects come from. I mean, if we think about Gilbert White, who is, as you showed me, a parson naturalist, sounds like someone who's interested in the natural world in a kind of like gentlemanly scholar kind of way.
Precisely.
But if you're trying to figure out properties of the soil through decomposing tea bags, whose idea was it to do that? And what can you learn from a tea bag decomposing that you wouldn't be able to learn in different ways?
I think really what this is about is finding ways to democratize the process of expanding knowledge. So involving people in that knowledge generating process who aren't necessarily scientists or specialists themselves. And that's in and of itself valuable for people like you and me who work in a heritage environment. We're here sharing our knowledge and the knowledge of wonderful people like Alice with the rest of the world. That's all part and parcel of the plan. But the other really good thing is it's cheap and cheerful. You know, if you can involve people in the process and they're happy to do it anyway, you know, there are massive funding challenges in academic research, in heritage practice. You know, if we can involve other people in doing that with us and bring them along for the journey, that's wonderful. And I think you have some really good examples of where that's happening in terms of your area of specialism, Alice.
Yeah, the work you were talking about, Ollie, where you were talking about school children going out and looking at what crops growing in which field, that information now is gathered by governments and by organisations. We kind of know that there are opportunities for using satellite imagery to look on a landscape scale at what crops are growing where and when. But it's much harder to really monitor biodiversity, to monitor the amounts of insects, for example, that are living in different pockets within our landscape. And so that's a really nice opportunity to link up citizen science with agricultural areas, encouraging members of the public, like you're saying, to come on and do some of that monitoring process alongside farmers. So one of the projects that we're working on at the moment is called the Showcase Project. It's a project that's funded by the EU, and we've got partners all across Europe. And citizen science isn't something that's that familiar to some of our partner organisations in other countries. The UK is really quite leading in terms of citizen science as a concept. We've got loads of different citizen science schemes looking at a whole range of different issues in the UK. But the nice thing, as Ollie was saying, is that it's about democratising science. It's about bringing lots of people into the process of science, understanding the scientific method, but also by generating large amounts of data from geographically different areas, we can gather very large data sets very quickly that would otherwise be very costly if scientists themselves were actually doing the data collection. And the concept of citizen science is all about open data. So that data is then freely available. And if we get these very, very large data sets, we can start to answer some really interesting questions.
They're big data. I think there's another really interesting outcome of some of these projects, and it connects in some ways with a recent program of activity emerging from the Right to Roam movement. And the Right to Roam movement are often thought of as directly opposed to farmers and landowners because there's a tension there. But I think their very recent publication, Wild Service, which is a sort of edited volume of short essays about engagements with rural and natural environments, an awful lot of that rings very strongly with the idea of citizen science or involvement or wider public involvement. The sense that somehow playing a part in supporting some small element of biodiversity or environmental protection gives you greater connectivity to nature. And that's so significant and important. We're sitting in the middle of, obviously, quite a green campus in the heart of Reading, but Reading is a major urban centre. So anything that we can do to encourage people from those kinds of backgrounds and environments to have greater connection to the countryside, to rural, to natural or semi-natural environment, is really important. And the other strength in that is it's sort of bringing people together around a shared and common inheritance in terms of our wider landscapes. And farmers obviously have a stakeholder in that. Urban dwellers have a stakeholder in that. We've all got a stakeholder in that. It's so important for the future. So anything that brings all of those stakeholders together through shared activity will hopefully align us all.
Yeah, absolutely. And not all farming approaches are the same. Many farmers now are really looking to change their farming practices towards more sustainable farming practices. So we talked earlier about integrated pest management, but farmers are very much looking to look for the natural biodiversity to support crop production. So as I was saying, looking at supporting parasitic wasps or other beneficial insects within the farmed landscape. And so by having citizen scientists there to help monitor populations, both of our natural biodiversity, but also those beneficial insects, gives information to the farmer, helps them understand which areas are maybe best for supporting biodiversity and maybe less useful for food production. So this balance of food production within a sort of wild environment is a change that's starting to happen, this concept of sustainable agriculture. And that's really what my research has been focused on, is sort of, in the broadest sense, how we can make our agricultural food production processes more sustainable.
If you were looking to the future of sustainable ecology, what would you hope to see in the next 5 years or 10 years? Is that too short of a timeline?
I think farming is changing, and we are having to think about ways to adapt to the changing climate and to other factors that are changing, other economic factors. So if we're thinking about sustainability, we need to think about everything kind of in balance. So we've got economic sustainability, we've got environmental sustainability, we've got social sustainability, those three key pillars. And if our systems, our food production systems, are going to be sustainable, we need to think about all of those in balance. And there's another change that's coming as well, especially here in the UK, the conversation around regenerative agriculture. So almost moving beyond being sustainable, something that could be sustained into the future, something that's regenerative and starting to restore what may have been lost, certainly starting with our soils, what's been lost in our soils. So I think farming systems are going to change over the next 5 to 10 years quite quickly, because we've got clearly an environmental crisis in terms of the climate crisis, and we've also got a biodiversity crisis. We're losing biodiversity, so things need to change fast, and I think farmers are on that journey.
Well, and I think that's why citizen science is so empowering, because it kind of helps us reclaim that term of scientist. There are people like yourself who've done a lot of work to be able to do science and understand it from a professional level. But I also think giving people ownership of their ability to look at, analyze, and interact with their own sort of natural habitats and ecosystems is really powerful, because making that change from sustainable to regenerative requires that we really know the land that we're living on and the species that we share it with. This all feels very kumbaya, but I mean it. It's just makes me want to go out and count butterflies.
Well, you can. There's many opportunities to do that. We've been working with Butterfly Conservation. They're the organisation here in the UK that are championing butterflies and moths, and they've got a citizen science scheme. They've got the garden butterfly survey that runs every year. If you want to look at birds, there's bird surveys run by the RSPB and others. So there's lots of citizen science schemes that are available that are very accessible for people to be able to record what's going on in their gardens. But there are also equivalent schemes that are run on farmland. And we were talking earlier about sort of access to land, and that's one of the things that when we were doing a survey as part of the Showcase project, we were talking to local wildlife recorders, our citizen scientists that were collecting biodiversity data on farmland, and we were asking farmers how they were going to use that information. And the farmers were telling us it was very valuable information to them to know what species they have, what habitats they can support that biodiversity on their land. But for the citizen scientists, they had opportunities to maybe access private land that they previously didn't have access to before. So it worked very nicely as a sort of partnership.
Yeah. I want to kind of bring us right back full circle to the moment when the museum comes into being. There's a founding collection that comes into the object collections of the Merle in 1951, and it's amassed by a guy called H.J. Massingham, and Massingham is a rural writer of the interwar period, so between the First and the Second World Wars. And one of the books he writes is about this object collection, and it's called Country Relics. And in that story, he's essentially setting these older objects in context and thinking about the part they would have played in local and sort of regional specific styles of farming. What's interesting about Massingham is, there are two things. First is he's also around about this time publishing selected writings of Gilbert White. So he's interested in Gilbert White, and he takes his object collection and he sticks it in a hut in his garden, which he calls the Hermitage. And the Hermitage is the name that Gilbert White talks about in relation to a folly that he has in his own garden. So there's a connection there. He's inspired by White as a naturalist, but he's also a pioneer of organic farming. So he's a great supporter of what goes on to become the Soil Association, founded again around that post-war period. Organics obviously has a lot in common with and overlapping with regenerative farming, but it's slightly different. But it's taken a long time for us to come round to this idea of focusing more heavily on soil health. So I guess I want to finish, Alice, by asking you whether you're hopeful about that shift to regenerative farming, or whether you think it's going to take us 75 years to get our head around the fact that that's important, and by that stage maybe it'll be too late for the butterflies and the birds, no matter how much we count them.
I think we have to be positive. We have to feel that there are changes that we can make that will make a positive difference. And I think regenerative farming is yet to be defined really clearly. But that concept of trying to build back what may have been lost in terms of biodiversity loss, but also in terms of sort of soil nutrition and health, I think it will take time. But there are major retailers. The University of Reading are working in partnership with Waitrose, for example, and they're moving all of their suppliers to regenerative farming practices. So while there's those big changes happening out there, I do think that we will start to see improvement. With working in partnership is always the best way.
So we can have people power from the purchasing end of the food system,
all the way
making
through.
a difference right the way through to people involved in citizen science.
That does it for this episode of Absolute Units. We'd like to thank Alice so much for being here. Is there anything you'd like to plug before we end?
Well, it's been really great to be here. Thank you for the opportunity to come and chat. I've enjoyed talking about some of the projects I've been involved with. My research is mainly funded through EU funding, which is great because they're large collaborative research projects. One of them I've mentioned is the Showcase project, but I'm also working on Value for Farm, which is looking at ways to incorporate renewable energy production into farmlands where we're producing both food and energy from the same landscapes. And also the Follow project, which is looking all about defining and measuring food loss and how we can minimise food loss in our food production systems. So thank you very much for having the opportunity to chat about my research, and maybe come back and tell you about those projects in due course.
Yeah, we'd love that. That sounds really exciting. Thank you so much. We'd also like to thank the Arts Council for making this show possible, as well as the Film, Television, and Theatre Department of the University of Reading. This show is a production of the Museum of English Rural Life as part of the University of Reading and Museums Partnership Reading. Thank you all so much for listening, and we'll see you next time.